at Level by an Academy. In this video, we are going to discuss this problem, largest scale. So let me firstly tell you that what we are going to cover in this video. So firstly, we will check out the problem statement. After that, we are going to discuss the approaches to solve this particular problem. Then we will discuss the time complexity as well as the implementation of this particular problem. So let's just start with the problem statement. Here this problem statement says you are given two integers q and l. Let's take an array A that is initially empty and you have to answer q of the below query. In each query there would be an integer v. You have to append v to the array and then print the sum of k largest elements of the array A. And if the size is less than k, then you can just print the sum of all the elements of A, right? So what would be your input format? Your first line would be containing two space separated integers. First would be q, that is number of query, and second would be k, right? K would be showing that you need to print the sum of largest k elements at every query. Output format would be q space separated integers, and for each query you need to print the sum of k largest elements of the array. If the size of A is less than k, then you need to print the sum of all the elements of A. Here the constraints are given. Your number of queries would be less than 10 raised to the power 5. Your value of k would always be less than your number of queries. And every value that would be given to you in the input would be less than or equals to 10 raised to the power 9. And here one of the sample output is given for your reference. Now let's discuss this particular problem with the help of given sample input and output. Here it says that you are given two integers q and k. So let's take this particular sample input where your q would then be equals to 5 and your k would be equals to 2. Now next is, it says that let's take an array A that is initially empty. So we are having an array A which is initially empty. You have to print answer of q queries as given below. Each query will be having an integer v and you need to append v to the array A and then print the sum of k largest element of array A. If the size of A is less than k, then you need to print the sum of all the elements of array A. Okay? So basically, this array A would be having all your queries, right? It is just asking us to append every query V to your array A and print the k largest elements. So we can say that if your queries are this, that 5, 1, 2, 4, 3, these are your 5 queries. So for Q1, that is your query number 1, what we will do, we will push 5 into your array A and your sum of k elements. Here the value of k is 2, right? Here the value of k is 2. Sum of largest two elements would be equals to 5 only, because here you can see that your current length of the array is less than your value of k, right? Then for your query q2, your array A would become 5, comma 1. The next query 1 would be pushed. Then your sum of k elements would be equals to 5 plus 1, that is 6, because right now we are only having two elements. So we will give their sum. Now moving forward, here you can see this was for index 0, this is for index 1, 2, 3, 4. So we can say it as 0th query, like at 0th index. This is our first query at first index, right? Now similarly, moving forward, here for your Q2, that is for index 2, your twelfth query would be A, which would be having the elements 5, 1 and 2. So now your problem starts when your index would become equals to k, when the index at which you are pushing the value becomes equals to k, or you can say that your length of the array, here the length of the array is 3, it is greater than k, right? Then your problem starts. But your problem is that right now we are having the elements which are more than k. So you need to find the top k elements, or you can say the largest k elements. Here, the elements would be, if we will write them in sorted order of non-decreasing order, then top two elements are 5 and 2, and you can say the sum of top k elements would be equals to 7 now, right? Now your array is, if you have sorted this array, now your array look like this. Now for index 3, that is your query q3, you are having the element as 4. So in your array you are gonna push this as 1, 2, 5 and 4. Okay. Now also your last index at which you have pushed the element is greater than k, right? So you have to find the total top two elements. For that you would again sorting the array. So if you will sort the array, it would be 1, 2, 4, 5. Then sum of top k elements would be equals to 4 plus 5, that is 9. Then for your last query, that would be q3, your array would become 1, 2, 4, 5, and the last element that we are pushing now is 3. So here also we need the sum of top two elements. For that you would need to sort the array as 1, 2, 3, 4 and 5. Top two elements would be 4 and 5, and their sum would be 9, right? Simple enough. Now let's see the approach that we have seen right now. What would be the time complexity of it? Okay. So here you can see, firstly we have traversed for all the queries. Firstly, we are traversing for all the queries, that would be of q. Then for every query, we are traversing through all the elements to get the sum. Like we are traversing through k elements to get the sum, right? So we can say that for every query, we would at least traverse through k number of elements to get their sum. So it would make your complexity to big of k into q, that for every query q you would be traversing k elements to get their sum, right? Simple. Now what we are doing next, so here you can see, once your index I at which you are pushing the new element becomes equals to k, you would need to sort your array every time for every query, because you need to get top k elements. So here you will sort the array, here also you will add a new element and sort the array. Here also you would be adding a new element and you would be sorting the array. So if there are total q elements, you are sorting, you are performing sorting q minus k number of times, because for first k elements you were only doing the addition. But after your elements in becomes more than k, then you have to perform sorting every time for q minus k elements, right? For q minus k times, right? So here what would be after your I becomes equals to k, you will need to perform sorting. How many times you would be performing sorting? So here, here and here. So we can say that it would be q minus k times you are performing the sorting, q minus k times. But you are performing sorting algorithm on all the q elements, right? So here we can say that the time complexity just for sorting would be, so as you know, sorting takes q log q time, q log base to q time, right? For q number of elements. And how many times we would be performing this? Q minus k times, right? If I will take, if I will take this k a very small value, For example, let's assume that k is a smaller value in comparison of q. Then your time complexity would be q square log base to q. As we are ignoring the subtraction part, k q log base to q. As we are ignoring this part that k can be a smaller value, so let's just ignore it. So what would be our total time complexity? This is the time complexity for your sorting, and this was the time complexity to get the sum. So here we can say that total time complexity would be k into q plus q square log base to q, right? Simple. Now if you remember that what was the constraints for q? For q the constraints were 10 raised to the power 5. Q can go up to 10 raised to the power 5. So, if your Q would be equals to 10 raised to the power 5, then Q square alone will give you the time complexity of 10 raised to the power 10. And as you know, we can't perform this much of operations in the time span of 1 second, right? Cool. So, we would need to optimize the time complexity. Now, let's see how we can optimize the time complexity. So, from looking at this particular part, one thing that we can think of is that maybe we can do something for which we would not need the sorting every time, for which we want to be sorting all the elements every time, right? So, let's see if that is achievable. If we are having k is equals to 2, our q is equals to 5, all our queries equals to 5, 1, 2, 4, and 3, then tell your I is less than k. That means your index. So if your I here is 0, 1, 2, 4. Till your I is less than k, that means total number of elements are less than or equals to your k number of elements. In that case, it's good. We just only need to take the sum. So here what we can do is, we can just take a variable sum here, which is initially 0. So we can take a variable sum here, which is initially 0. Now for our zeroth query, when I is equals to 0, that means your query 0, our current element would be 5. So we can make our array. In this particular array, we can push this element 5 and we can add this 5 to our sum. So sum would become 5, right? And as we would be storing somewhere all the sums like for every query. So let's say we are having this sum array, and in this sum array we would store the sum for every query. So firstly for every query, so let me just mark the indexes. So for zeroth query the sum is 5. Now we would move to the next query when your value of I would be equals to 1. So this is your first query. Now in your array we are having the element 5. After that we will push the next element, that is 1. So 5 comma 1. Now as here your I is still smaller than k, that means your number of elements are either less than or equals to k. In that case, we will need to take the sum of all the elements, right? So here, our sum would be equals to, we don't need to traverse through all the elements till now to get the total sum. What we can do is, we can check what was the sum till our last index, and we can add current element to it. It would give us the total sum till index 1, just because we know that elements that have been occurred till now, their sum is at my last index. I need to get the sum of all the indexes till now, so I can add my current element to it. So till now the sum was 5. I can add my current element to it and the sum would become 6. So here the sum is 6, right? Now let's move forward, and here your I would become equals to 2. So we are having a new element which is 2. that we need to push now in the array. So let's just push this element. Our array would become 5, 1 and 2. Now here, as you know, that we will need the top two elements, top k elements, right? So for that, firstly we would need to sort the array. So let's just sort the array. And here, after sorting, we will get 1, 2 and 5. Here, what we will do, we will just traverse for the last k elements, and we will take their sum. So sum would become 7 here. We will just update our sum as 7. So here you can see we have done the sorting. But we were trying to avoid the sorting. Why we have done this sorting here? So we have just done this sorting only for this particular part when your I would become equals to k. We won't do your sorting again. Let's see how. So here, your next element for I is equals to 3, that is your third query, would be, next element would be 4. We will push it into the array. So your array is sorted now. So your elements would be 1, 2, 5 and 4, right? So as you know, your sorting takes n log base 2n time for n elements, right? So what we can do is, as we know, our array till now was sorted, only a new element is added to it. So what if we will place this new element at its right position? How we can do that? So firstly, we can traverse through the array that at which particular place we can fit this element. So you can just check, is there some position in your array where, let's say, array of some index j would be smaller than or equals to your current element 4, and your array of j plus 1 is greater than this element. If you will find this place, then you can place your element at j plus 1 index. That would be its correct position, right? So you can see here, if array of jth element is, if array of jth index is smaller than your current element and array of j plus 1 is greater than your current element, then you have to place your element at j plus 1. That would be its right position. So here, what we can do, for your this array 1, 2, 5, 4, indexes are 0, 1, 2, 3, we will find the right position for 4. So we will check, is this index satisfies this condition? No. Is your index 1 satisfies the condition? No. Is your index 1 satisfies the condition? So you can see yes. Here array of 1 is 2. Here array of 2 is 5. Your 4 should be placed in between 2 and 5, right? So what we can do, after finding your correct position, so your correct position would be this, right? Your correct position would be index 2. So what we can do, every element starting from index 2, we can move them one space towards the right. So here, this element, we can move it towards one place right. So if we will move it towards the right, 5 would be placed here and there is no element after this. So we can just put our current element here, and you can see after putting our current element at the right position, our array is sorted now. And how much time do we have taken for this, making this array sorted again? We have taken n time. We have taken order of n time. How order of n? Firstly, to find the correct position, we have taken time from index 0 to j. Then to shift all the elements from j to end, we have taken time from j to your n, right? So total time taken here would be big of n. So it is much less than n log n, you can see, right? After we have placed the elements at its right position, we can take the sum of last k element, that would be 4 plus 5. So here your sum would be 9. We can update the sum in our array, that for our sum array output would be 9. Now let's deal with the last query, that is 3. So here your Q4, when I would becomes equals to 4, your query is 3. So now your array is something like this: 1, 2, 4, 5, and we will push our new element at the end, 3. Now again, as we know, 3 is not at its right position. We will make it reach to its right position. So to find its right position, we have this condition that array of j should be smaller than or equals to element, and array of j plus 1 should be equals to smaller than or equals to the current element. So is 1 satisfies this condition? No, because 2 is not greater than 3. Is 2 satisfies this condition? So yes, 2 is less than 3 and 4 is greater than 3. So ideally, our 3 should be placed here in between 2 and 4. So now we know this particular index 2 is the right position to place your 3. So what we can do here? So we know that j plus 1 is the right position. Okay. So what we will do? Firstly, we have found the right place. Now we will shift everything from this right place to the end, one place towards the right. How we can do that? So see, firstly we will move 5 at its right. So 5 would come here. Then we will move this 4 at its right place. One space right, one place right here. So 4 would come here. After placing 5 and 4 there, we would just place your 3 here. Okay. So now we can say that your array is 1, 2, 3, 4, and 5, right? And now we need to take the sum of last k elements. The last two elements are these two. So the sum would be equals to 4 plus 5, that is 9. So here you can see what we have optimized in the terms of time complexity. So we are not sorting at every index. Here instead of going n log n for every query, we are just traversing for n elements, right? And for first k elements, you are not traversing through all the k elements to get their sum. We are just getting the sum with the help of last element, right? So if the sum, we already have the sum till the last element, we can just add our next element here. Okay. So here, what would be the time complexity? Here you can see we are traversing all the n queries. So it would be your n queries. For n minus k queries, we are traversing for k time to get the sum. So for n minus k queries, we are traversing k times to get the sum. And how many times we are following this? We are traversing through this n. So that also we are doing n minus k times. So it would be into n, right? So this would be your new time complexity, right? And as you can see, we have optimized it from this place. Okay. And here your n is basically the number of elements which is equals to your number of queries. Okay. Your n is equals to basically q. So you could have written it as q minus k into q, right? So let's just see how we can implement this particular approach. So here, let's say your k is equals to 2 as given in your example, and let your number of queries are equals to 5, and let's take your queries array. So queries 5, 1, 2, 4, and 3, right? Now let's find out the result for k largest. So let's say let result is equals to k largest. Here we are passing our k, q and queries. And at the end we can just console.log result. So let's just implement the k largest function. So here it is, function k largest. So here we would need to create, one would be our output array, or you can say the sum array, which is initially empty. And similarly we will need our one other array to store our elements. So let's name it as array. Now as you would be having q queries, and we would be having one index for every query in your array. So we can just have a loop for this, for let index is equals to 0 till index smaller than your number of queries. We are saying smaller than q just because we are starting your index from 0. So if there are q queries, then in terms of index we can say it would be from 0 to less than q. And every time we are doing index plus plus. Now for every query you would need to result some sum. So let's say initially the value of sum is equals to 0. And as we know, if your index is less than k, then the process would be little different. And as you are getting a new query, so you need to push that element given in the query to your array also. So we can just say that array of index should be equals to your sum array, your queries of index. And as we know, if your index is less than k, then we will deal with the elements in one way, otherwise we will deal with the elements in other way, right? So let's say if index is less than k, then what we are going to do, so in case if this is your first element, that means your index is equals to 0. In that case we can say our sum is equals to your first element only, that is array of 0. Otherwise, if your index is greater than 0, in that case what we're gonna do, so we know that in some array for earlier indexes your sum would be stored at index minus 1, and you can just add your current element to get the total sum till now. So here we can say that your sum would become your sum till now, that is sum array of index minus 1, and you can just add your current number to it, which is your array of index, right? So this was what we're supposed to do when your index is smaller than k. Now what we want to do if your index is equals to k or larger than k. So we have seen that if your index would be equals to k, then firstly for one time we need to sort the array. So here we can say that if your index becomes equals to k, then you will need to sort the array. So we can just say array dot sort. Otherwise, if your index would be greater than k, in that case what you need to do is you need to place that last element which you have pushed in the array to its right position. Okay, so let me say it as my current element. What is my current element? It is your array of index, that is basically your last element. And what we are going to do, we are going to place this current element at its right position. How we can find its correct position? So let's say let correct position, initially your correct position is equals to, let's say, index only. And after that we can just traverse through your whole array. So from 0 to I smaller than or equals to your index and I plus plus. Oh, let me put it as let. And we don't need to go till index. We can just do smaller than index. As index is at index, it is already there. So we can just check if your array of I is smaller than or equals to your current element, and
बिना दस में
your array of I plus 1
बदमाशी
is
नहीं
greater than
यही
or
सिखा है
equals
हाँ
to your current element. In that case, I plus 1 is our right position to put our current element.
चलो बाल
So
कटाने
we can
जाएंगे
say our correct position for current element is I plus 1. So here we don't need to go further and
बाल
we can
कटवाने ले
just
जाएं
break here, right? So we are just traversing until we are finding the correct position. After that, we will not traverse the array. So here it was just to find correct position of current element. Now we will need to place this current element to correct position. So place
तो सामने नहीं होता
current element at correct position. For
तो
that,
सामने
we will need to shift elements after your correct position to one place towards the right. So how we can do that? We can just start from last element, that is from index minus 1. So let I is equals to index minus 1 and we will go till your correct position. So I greater than your correct position and I plus plus. Here what we can do, we can just say that place current element one position towards the right. So your array of I plus 1 would becomes to would become equals to array of I. So this is how we have placed all the elements starting from correct position to index minus 1, one place towards the right. Then after this, we can place our current element at its correct position. So your array of correct position would becomes equals to current element, right? So we are done with placing our element at its right position. So it is same thing that for index equals to k we have sorted. If your index is greater than k, then we have placed that last element at its right position. After this, what we are going to do, we need to find the sum of last k elements, or you can say largest k elements. So your largest k elements would be there at the end of the array. To get their sum, we can just put a loop here that for let I starting from index from the end, right, till I
बाल
greater
कटाने
than or
जाते हैं
equals to your index minus k. And every time we can just do I minus minus. And in this loop, we can just do sum is equals to sum plus your array of index. This will give us the sum of top k elements for our current query, right? Now, in this current query, after calculating the sum for every case, what we need to do is we need to place that sum in our sum array. So your sum array of current index should be equals to the calculated sum. And at the end, what we can do, we can just return your sum array. Okay. So let's just walk through this particular code once. That what we have done here. Firstly, we have taken the values of k and q. Then we have taken all the queries. After that, we have called this function k largest, which would give us the sum of k largest numbers for all the queries. Then in this k largest function, we have taken two arrays. We have called this k largest function. And in this k largest function, we have created two arrays, sum array and array. Sum array would be storing the sum at every query, and array would be storing the elements of our array. Then we are going through all the queries. Initially, the sum is 0. Then the new element that you are getting from the queries, you will push it to your array. If your index is less than k, that means we need to return the sum of all the elements till now. So how we can do that? If your index would be equals to 0, then you can just return your first element. Otherwise, we know that some of the elements till now is already stored in our sum array till our last index. So we can just pick that up and add our current element to it to get the sum till now. it is just like your prefix sum array. Okay, we already have the sum of other elements like earlier elements prefix sum. We can just add our current element to it to get the total sum till now. Otherwise, if your value of k would be equals to index or greater than index, then what we are going to do? Firstly, for the index equals to k, you would need to sort the array. Otherwise, if your index is greater than k, that means your array would be already sorted at equals to k. Now you just need to put the last element at its right position. So firstly, you will find out the right position for your current element. And how we are doing it? So we are just finding a place where your array of 5 would be smaller than or equals to current element, and array of 5 plus 1 would be greater than or equals to your current element. Then we know that in that case, I plus 1 is always the correct position. We can just break there and we can shift all the other elements from index minus 1 to your correct position to one place towards the right. So we are just doing array of I plus 1 should be equals to array of I till your correct position. After that, we can just put your current element at its correct position, right? So now we have placed our last element also at right position. After that, we will just take the sum of last k elements. So we'll start from index I from index. We will go till index minus k and we will do, oh, I'm so sorry, we will do I minus minus every time. We won't do this plus plus, okay? And we will, every time, we will just add the sum to our array of index, okay? Not array of index. Index is constant. So every time we will just add array of 5. Okay. So here we are taking the sum of last k elements starting from index till index minus k. In sum, we will add array of I every time. Now, after these cases of if and else, what we are going to do, we will push our sum into our sum array. So we have pushed our sum to sum array. When we would do this for all the queries inside this loop, at the end we can just return our sum array. So we have returned our sum array. Now let's try to run it. So here you can see we are getting the expected output 56799. For first element it would be 5, then for two elements it would be 5 plus 1 6. Then we will push 2, it would be 5 plus 2 7. Then here it would be 5 plus 4 9, and till the end 5 plus 4 are the largest two elements, so at the end also it is 9. Cool. So I hope this particular solution is clear to you and you would be able to solve the similar problems also. So thank you, take care.